Welcome. Today question 59. Looks like same as last few questions, but change is there. See, earlier classes, what you have done is, this weight, see, A and B or 1 or 2, this data given, weights are given. So, see, we solved 4 questions. 1. What force is required this way to prevent it from sliding down? What force is required this way? Next question, to move it up the plane. Next questions, I don't know which one order. What force is required here to prevent that from sliding down? And what force is required here to move that block up the plane? Now, question 59, what I am doing is, this is some examination question. Two blocks A and B are connected by a cable. To R are not, as per grammar, that R is not there. Okay. Two blocks A and B, connected by a cable which passes over a smooth pulley. Okay. B, okay, R. Okay, R is there. Okay. R is there. Okay. R connected by a cable which passes over a smooth pulley as shown in the figure. See, this is smooth pulley, this is the cable. It is parallel to the plane, understood. See, this line parallel. Then, coefficient of friction, I have given written here, this is 0.2, 0.25, or they can tell coefficient of friction for contact surface of block A and inclined plane is 0.2 and that for block B is 0.25. Now, 20 degrees, 60 degrees. One of them is T. Weight of block B is 6 kilonewton. This weight is given. 6 kilonewton is nearly 600 kgs. Maybe, for understanding correctly, 600 kgs, maybe a car, little lightweight car. Imagine, lightweight car. Okay, now, find the minimum weight of block A. Two questions are here. See, right here, two independent questions. You make a note here. Two independent question which can be combined together. I will explain that one. Okay, one, to prevent block B from sliding down. Second one, to move the block B up the plane. This weight, this is 59. Next class, today only one question because nowadays I got a lot of commitments, so I am not able to take too much time, give too much time for this recording. Half an hour I will take. Okay, now, next class what I will give is, I will explain now only, this weight I will give. I will ask that weight to prevent block, see, now they want this weight of block A. See, this weight, see, the question is, they are asking what is the weight here. One, to prevent block B from sliding down, then they want weight to move the block B up the plane. Next, I will explain now only. Next class I will tell. Already explained previous class. Next class question is, next class this question 60 and another two questions are there. I will tell you. Next class what I will do is, I will give this weight of block A I will give. I will ask what is the weight of block B once to prevent block A from sliding down, and then second one to move the block A up the plane. Next class. Okay. Now this is a question. Okay. See, solution. I want that space. Let W be the weight of block A. See, W suffix is not required because, see, this is unknown, this is known. So W1, W2, W, see, no need of writing WA, WB like that. One is unknown, so let it be W. This is 6 kilonewton weight. 0.2, 0.3 given, 20 degrees, 60 degrees. This is the cable, and let T be tension in the cable. Some statement you have to write. Those who are serious should write. Since the cable passes over, see, I am dictating. Since the cable passes over a smooth pulley, the tension in the cable T is constant. Write that one. So, if this is T, this is also T. This I told you last time. Okay, now, class, very important. I will tell today's class. Next class, once again I will explain. See, class, what is the question? To understand the question, do one thing. You take one somewhat flat road. See, road goes this way. Other steep road is there. A car is parked here. A car is parked here. Car, lightweight car. Then this car has, see, you found that the brakes are not working. So it will fall down. So friction is there, still, see, steep angle, 60 degree, it will fall down. So what they want is, they will put a cable here, see. They will put a cable here. I will show cable red color. Okay. They will put a cable here and attach the cable to one more block here. This is your block B. This weight is known for you. How much weight? Weight is 6 kilonewton. This is block A. Weight is W. Weight is W. That W you have to find now. There are two questions are there. See now, I will tell what happens. See, the cable will pass here and attach to its weight. If this weight block is not there, this car will fall down. It will slip down. Okay, now, if this weight is, see, now you slowly increase the weight. What will happen? As you increase this weight, see, this increase the weight, see, this weight has got component like this also, along the plane, perpendicular plane. As you increase this weight, the slipping of that car down is slowly reduced. And finally, one particular weight, just randomly I am telling, weight W equal to, for example, say, some random number I will tell you. I don't know how much number. Okay. 4.8, it will come more actually. Okay. 8.2 kilonewton, just like that. When the weight of this block is 8.2 kilonewton, then that block cannot slide down. It wants to slide down. So this will prevent it. See, little heavy weight here. So what will happen? This is on the verge of sliding down. Then this will be on the verge of going up. So at 8.2 kilonewton weight here, see, to prevent the car from sliding, you require a weight of at least 8.2. If it is less than 8.2, it will slide down. Now, 8.2, it will not slide down. Now, increase the weight further. See, same way, W becomes 15 kilonewton. If you increase the weight to 15 kilonewton, what will happen is, this will start sliding down here. See, this will start sliding down. That was equally important. See, this one will start sliding down. What is 1 minute now? Let me see what is the tan inverse of that one. I want that number. Where's the calculator? I don't know. Where I kept the calculator? See, sometime what happens is, I see here. Shift tan inverse 0.2. 11 point. Okay. Tan answer equal to tan 11. Okay, done. Now, if this weight is furthermore, then this will have tendency to go down. What will happen? It will come down, it will pull it upwards. See, suppose for example, see, this weight, lesser weight here, say for about 8.2 kilonewton, that will be on the verge of sliding down. If it is less than 8.2, it will slide down. Okay. So at 8.2, it is just prevents it. It is on the verge of sliding down. Now, if this weight is more, then this vehicle or whatever it is, this will start sliding, tendency to go this way. Then finally, it will overtake the friction, and at 15 kilonewton, this will start sliding this way. When it starts sliding this way, this will move upwards. See? Or still, for example, I will tell one more example for you. Imagine, see, you want to draw water from a well. See, you know how to draw water from a well. See, bucket is there, water is there. This is the water. Rope is there here. See, then over pulley it will come. See, this force P. As you pull this way, one particular weight, this is on the verge of coming up. On the verge of coming up. It is the reverse actually now. Then It will, so it is on the verge of coming up means it wants to go down. If you increase the weight, finally it will start moving up. So therefore, see, at 8.2 kilonewton, this will just prevent it from sliding. At 15 kilonewton, it will lift it up. So 8.2, between 8.2 and 15, this system will be in equilibrium. See, if you apply anything less than 8.2, this will slide down. If you apply more than 15, this will slide down. Then that will go up. So no equilibrium. So between these two, it will be in equilibrium. Therefore, make a note. In the class, the question can be asked in different ways. See, here simple language I told. One question is to prevent block B from sliding down. Next question, what is the weight here to move the block B up the plane? Remember, two independent questions. Okay. Now, this question can be asked in different ways. Right here, different ways is find the minimum, see, minimum and maximum weight of this block A for equilibrium. Minimum weight of block A is to prevent it from sliding down. Maximum weight of block A is to, then block A will slide down, that will go up. Or one more thing they can ask, find the range of W, find the range of this weight for equilibrium of the system. Range means from least value to highest value. Least value 8.2, highest value 15. See, less than 8.2 means lightweight, that will fall down. 15 means this will come down. Then that will go up. This is the question. So, or they can ask simple language, for what weight W this block is on the verge of sliding down. Or for what weight, second question, for what weight of this block A this is on the verge of going up. All means same. Okay, this all you make a note. See, class, question can be asked in different ways. Now, I will first explain for one. See now correctly, right here. Those who are serious, you write everything. First one is to find W of block A to prevent block B from sliding down. Sliding down. Therefore, this weight, if this, suppose imagine this weight is removed, that will slide down. Means what? Means block B is on the verge of sliding down. Sliding down. Then, right here, then block A is on the verge of moving up. Moving up. When this is on the verge of sliding down, this is on the verge of moving up. Therefore, when I put sketches later, I won't explain. The friction here will be, see, this is on the verge of sliding down. This friction is like this. See, friction force here. Limit all will put later. Whereas, when this is on the verge of sliding down, this is on the verge of moving up. So, this friction is like this. Make a note. So, this question, when I solve question number 1, that is the least value of P or minimum value of P for equilibrium, that is to prevent block B from sliding down. So, when it slides down, friction is up. Automatically remember, when block B slides down, block A has to move up. So, when it moves up, friction is this way. Oh. This is for 1. Then do one thing. Once you finish that one, write a note for 2. For 2 is what is the value of W for moving block B up the plane. Up the plane. That is, this time what will happen is, see, this block B, for a higher value of W, this will slide down, that will move up. So this time block B is B is on the verge of moving up. When block B is on the verge of moving up, automatically block A is on the verge of sliding down. This time, this is on the verge of moving up. See, friction is like this. This friction force. FF limit you will put later. See, this is on the verge of moving up. When this is on the verge of moving up, this is on the verge of sliding down. This friction will be like this. FF here. Okay. I will explain once again. Later when I solve, I will write and solve. I won't waste time. I am taking more time for explaining. Now very little work for me. Why? Two free body I have to write and solve. That you can do it. I can give exercise for you. Therefore, remember now. Once again I will tell here now. First question is to prevent the block B from sliding down. Block B sliding down means friction is up, and block B sliding down means block A is going up, friction is down. Second question, to move the block B up the plane. Block B moves up the plane means friction down, and block A, when block B is moving up the plane, block A has to come down the plane. See, it is moving up the plane, friction down. This is moving down the plane, friction up. This much is sufficient. Okay, now I explained each and every concept. Now I will finish the class in just around 10 minutes. Why? I will write on the board solution for 1 and solution for 2, frictional direction. I will not assume now. Now, one more thing you have to write. As I solve, see, you have to write always. Let RA be the normal reaction for block A and RB be the normal reaction for block B. Then, T tension already over. Further, since this is the case of limiting friction, FF limit for block B is 0.25 times RB, FF limit for block A is 0.2 times RA. This is told hundreds of times. This all you have to write and then solve. Okay, now this sketch I will maintain. This I will remove. Remember, when this is sliding down, friction up. Here opposite. See, sliding down means friction up. This sliding down means this going up, friction down. When it is going up means friction down. Second question. When it is going down means this will go up. Sorry, when this is going up, friction down. When this is going up, this will come down, friction up. That much concept you should understand and write. So I took lot of time for explaining. Next class, when I do question 60, this much I will not explain. I will tell you, I will briefly tell. At that time, unknown is this weight. This is known weight. The question is, find that weight. Once for preventing it from sliding down, next is for moving it up, or one more language, for what weight, it is on the verge of sliding down, and for what weight other block is on the verge of going up, or minimum and maximum value of weight for equilibrium of system, or range of the weight W for equilibrium of the system. Okay, over. Now this all I will remove. This sketch will be there. Here I will prepare the sketches and I solve. Now I will write all the answer now, because why? Now nothing is there. Now if you cannot solve, once I put the free body, then mechanical steps. Okay, I'll prepare it. Okay, now I will solve. See, first question, to find weight of block A, I already explained. This is your block B. This is your block A. Okay. To find weight of block A, that is W, to prevent block B from sliding down. Now see, for block B, unknowns are RB and T. But for block A, unknowns are RA, T and W. So unknowns are more for block A. First consider block B. Or your unknown is at A means you should start from other block. Okay, start block B. See here. Block B this way. 60 degrees. Now, this is your XX. This is YY. This 60 means 30. 6 kilonewton sine cos thousands of time explained. Okay. RB, tension T, see here, tension T, and this already I told you, block B is on the verge of sliding down. So when the block B is on the verge of sliding down, friction is up 0.25 times RB. Okay. Now sigma Fy0, you should do it, plus RB, then minus 6 sine 30 equal to 0, you solve, RB will come 3 kilonewton. Sigma Fx0, I will take this way positive. So what is the answer? Minus T minus 0.25 RB plus 6 cos 30 equal to 0. This is told hundreds of times. Substitute RB, you get T. This I am not explaining. Okay, this is somewhat exercise for you. Exercise for practice purpose. Okay, now consider equilibrium of block A. See here, block A. Weight is W, RA. Block B, when it is sliding down, block A will move up this way. So friction is down and coefficient is 0.2 RA. By this time, you know the tension. See, this tension is known for you. This is YY, this is XX. See now, sigma Fy0, take this way positive, plus RA minus W sine 70 equal to 0. So what you will get? You will get RA equal to unwanted W into sine 70, equation number 1. Then sigma Fx0, take this way positive. You get, see, minus 0.2 RA, see, then minus W cos 70, first unknowns, W cos 70, this is not there, plus 4.4460. Now substitute RA equal to W sin 70, that is from equation number 1, you get minus 0.2 into W sin 70 minus W cos 70 equal to 0. W you take outside, calculate this value, take to other side, simplify, W will come 8.389 kilonewton. That means this system is on the verge of, you can tell, not system, that is, if the weight of block A is 8.389 kilonewtons, block B is on the verge of sliding down and block A at that time is on the verge of going up. Over. Now, second question. Nothing is there. Second question. I don't know how I put this way. To find weight of block A, that is W, to not prevent, to move, see, to move the block B up the plane. You make a note here, one thing forgotten, to find the weight means minimum weight, or it is what? Or you can write when block B is on the verge of moving up, that is much better. When block B is on the verge of block B, to move the block B up the plane. Up the plane. Or you can write much better. Last time you write block A is on the verge of sliding down. Now you write block B on the verge of moving up. Now what will happen is, see, again same thing. First consider block B, then consider block A. When you consider block B, I already explained, it is on the verge of moving up. So this friction will be down. See, this friction will be down. And here, when block B is on the verge of moving up, this is on the verge of sliding down, this friction is like this. This way. That's all. That's the only change for this question. Okay, start solving. Sigma Fy0 plus Rb minus 6 sin 30 equal to 0. Rb will come 3 kilonewton. Sigma Fx0, see now, minus t, but be careful now, minus t plus 0.25 Rb plus W cos 30 equal to 0. T will change. T will come 3 into 0.25 plus 6 into cos 30 plus 3 into 0.25. 5.946 kilonewton. T will come 5.946 kilonewton plus. Now more, see, tension came more, effort required is more. So here you write T 5.946 kilonewton. Okay. Solve here. Sigma Fy0. Same sketch, same explanation. Plus Ra minus W sin 70 equal to 0. Once again Ra will come W sin 70. But when you make sigma Fx0, see, instead of, last time it was this way, see, minus 0.2 Ra. Now it is this way. So it is plus 0.2 Ra. See, plus 0.2 Ra. Then minus W cos 70 plus this number is 5.946 equal to 0. Substitute Ra W cos W sin 70. I by mistake last time I wrote W cos 70. It's a print mistake, but I substituted W sin 70 only. See, don't find a mistake. By mistake I wrote cos 70. Actually it should be sin. If I put cos 70, see here, I should have put sin 70. I wrote sin 70 only. It is by oversight. Okay. W sin 70. Somebody may comment, wrong. Why wrong? See, next step. Next step I substituted correctly. By oversight, I was thinking of something else. Okay. Minus, see, for me, x is cos, y is sin is not compulsory. I can take any angle. I can take angle with yy. Then y will become cos, x will become sin. For me, no confusion, but for you, confusion. Okay. Minus 0.2 into W sin 70, not minus, plus. Then minus W cos 70 plus how much? 5.946 is 0. Surely your W will come much higher now. See, W will come 0.2 into sin 70. Last time, make a correction there. Sin 70. Then into minus 1 plus cos 70 equal to reciprocal into 5.946. 38.589. Such a high value. No, that is too high value. 1 minute. Cos 70. No, it is possible, not wrong. Cos 70 is 3.4. 1 minute. Cos 70. Oh, this is. So something went wrong there. No. Cos 70 positive. No, it is 0.2 into sin 70. That way, minus cos 70 equal to one number came into minus 1. Okay. Reciprocal into 5.946. Yes, 38.590. Yes, high force required now. 38.590. 38.590. Okay, correct, because anyway, if any calculation mistake is there, correct it. Don't blame me. See, last time it was small answer. Why? Last time this W should prevent it from sliding. But now you apply high force so that this comes down, that goes up. You require higher effort. I think I'll check once again. Is it correct? 0.2 Ra, 0.2 into sin 70, then equal to minus cos 70 equal to into minus 1 because it goes other side, reciprocal equal to into 5.946. 38.59, correct. Okay. Therefore, if the weight of block A is, last time I forgot the answer now, some 8 or 9 came, this will just on the verge of sliding down, but that weight will prevent it from sliding down. But if you increase the weight to 38 point something, then because of the heavy weight here, this will slide down, that will go up. That is the question. Understand. Next class, question 60, same question I will do. I will give weight of block A for you, find B. This much I will not explain. Briefly I will explain. Then another 2 interesting questions are there. Okay. Next class we will meet. Thank you.